January 1945. Somewhere in the collapsing interior of the Reich, the war no longer sounds like victory. It sounds like paper, the soft shuffle of documents, the scratch of pencils over engineering tables, the low hum of a lamp burning through another blackout night. In a secured room, German aeronautical engineers study photographs that were never meant to be seen here. Long wings, smooth fuselage, 4 engines unlike any in Europe. The scale alone forces silence. This is not a tactical bomber, not a weapon improvised for a desperate year. This machine has been designed for distance, measured in oceans. The men around the table do not argue. They calculate. They measure wingspan against known airfields. They estimate fuel consumption, pressurization tolerances, engine output. Each number confirms what instinct already whispers. This aircraft was not built to reach Berlin. It was built to reach anywhere. Outside, the Reich is shrinking by the hour. Inside, something else collapses quietly. The belief that German engineering still defines the limits of modern warfare. Because in these drawings, in these technical summaries, they see not just an airplane, but an economy, a doctrine, and a civilization capable of producing it. And as they turn the page, the realization begins to harden. This war has already moved beyond them. By the time the first credible intelligence references to the Boeing B-29 reached German technical circles, the air war over Europe had already entered its most destructive phase. Cities burned nightly, rail lines twisted into useless knots, refineries vanished beneath layers of ash and concrete dust. Yet for all its violence, the aerial conflict unfolding over the Reich still operated within assumptions Germany understood. The Luftwaffe had been built for speed, interception, and decisive campaigns close to home. Its doctrine, forged in the interwar years, emphasized operational flexibility and rapid results. Aircraft like the Ju-88 and He-111 were designed to support advancing armies, not to wage industrial war across continents. Even Germany's most ambitious heavy bomber concepts had been constrained by European geography and limited resources. The war, as German planners imagined it, would be fast. Industry would support victory, not define it. Across the Atlantic, a very different philosophy had been maturing. The United States entered the war with distance as both burden and advantage. Oceans insulated its factories, but demanded weapons capable of crossing them. Long before Pearl Harbor, American airpower theorists had embraced a vision of strategic bombing rooted in endurance, altitude, and mass production. The aircraft emerging from this thinking were not built to operate from captured airfields just beyond a frontier. They were built to operate from continents away. By 1942, American factories were producing aircraft in numbers that defied European precedent. Assembly lines stretched for miles. Components were standardized, interchangeable, designed for speed of manufacture as much as performance. German intelligence officers tracked these figures with growing unease. It was not merely that the United States could build aircraft, it was that it could replace them endlessly. In Europe, the daylight bombing campaign intensified. The B-17 and B-24 carved lanes through German airspace, absorbing losses that would have crippled any other air force. German engineers studied these aircraft closely. Captured wreckage revealed robust construction, redundant systems, and a tolerance for damage that reflected American priorities. These bombers were not elegant, they were survivable. They assumed attrition and overcame it through volume. Still, for German planners, these aircraft fit within a recognizable frame. Their range, while impressive, was finite. Their payloads, though heavy, demanded forward bases. The Reich could imagine countermeasures, improved fighters, better flak, new engines. The technological race, while grim, still felt competitive.
What remained largely unseen was what American engineers were building beyond Europe's horizon. In the Pacific, the problem was entirely different. Vast distances rendered existing bombers inadequate. Islands were separated by thousands of miles of open water, supply lines stretched thin. To strike Japan itself would require an aircraft capable of flying farther, higher, and longer than anything yet deployed. It would need to carry heavy payloads without refueling. It would need to function where failure meant disappearance into the ocean. The result was not an incremental improvement, it was a leap. When the B-29 program began, it consumed resources on a scale unfamiliar even to German wartime planners. Entire factories were built solely to produce its engines. New alloys were developed. Pressurized cabins, once experimental curiosities, became operational requirements. Remote-controlled defensive turrets replaced manually aimed guns, reducing crew fatigue at high altitude. Each feature solved a specific problem of distance and endurance, but together they formed something more radical. The B-29 was not just an aircraft, it was an ecosystem. German intelligence, fragmented by Allied bombing and internal rivalries, struggled to assemble a clear picture. Early reports were vague. References to a very large bomber operating in the Pacific seemed irrelevant to Europe's immediate crisis, but technical officers took note. The specifications, where known, did not align with any German design philosophy. Range estimates alone raised alarms. No Luftwaffe bomber approached them. Payload figures suggested an aircraft capable of carrying significant ordnance without forward staging. And then there was altitude, higher than most interceptors could reliably reach, sustained for hours. For German engineers accustomed to working within constraints, fuel shortages, material substitutions, shrinking industrial capacity, the implications were unsettling. This was not a weapon rushed into service under wartime pressure. It was the product of planning, patience, and industrial depth that Germany no longer possessed. As 1943 gave way to 1944, fragments of information accumulated. Reconnaissance summaries, Allied press releases filtered through neutral channels, technical intelligence exchanged in whispers between specialists. The picture remained incomplete, but its outline was unmistakable. Somewhere, beyond the reach of German bombers, an enemy was building an aircraft designed not for the next battle, but for the war after this one. And as German engineers compared what they knew to what they could still build, the gap began to feel less like a challenge and more like a verdict.
To understand what German engineers confronted when they examined the B-29, it is necessary to step away from the aircraft itself and look at the system that produced it. Because no single factory, no isolated design bureau could have brought such a machine into existence under wartime conditions. The B-29 was the visible surface of an industrial depth Germany no longer had. By 1943, the United States had transformed itself into a fully mobilized industrial state. Civilian automobile plants no longer produced cars, they produced bombers. Refrigerator factories turned out machine guns. Electrical firms manufactured avionics and fire control systems. This conversion was not improvised. It had been planned years in advance, guided by a belief that industrial output would decide modern wars. The numbers alone told a story German analysts found difficult to reconcile with their own experience. American aircraft production climbed into the tens of thousands annually. Losses at the front did not slow delivery schedules. In many cases, they accelerated them. Replacement aircraft arrived faster than units could be trained to fly them. The problem for American commanders was not supply, but organization. At the center of this system stood companies like Boeing. Unlike European manufacturers, which often balanced military and civilian contracts, Boeing became almost entirely devoted to the war effort.
Its facilities expanded rapidly, supported by government financing, standardized tooling, and a workforce drawn from across the country. Engineers worked alongside production managers, ensuring designs could be manufactured at scale rather than perfected in isolation. The B-29 reflected this philosophy at every level. Its design was modular. Components were intended to be assembled, replaced, and repaired quickly. Engines, despite their complexity, were built in multiple plants to prevent bottlenecks. Even the aircraft's size was a calculated choice. Larger airframes meant fewer aircraft could deliver greater payloads, reducing logistical strain over extreme distances. For German engineers, this approach contrasted sharply with their own experience. German aircraft design had long prized performance efficiency, lighter airframes, higher power-to-weight ratios. But such precision came at a cost. Production was slower, maintenance was more delicate, and as the war dragged on, shortages forced compromises that undermined reliability. The B-29 accepted inefficiency in exchange for certainty. It assumed engines would fail and designed redundancy. It assumed flak would strike and armored critical systems. It assumed crews would be exhausted and pressurized their working environment. Each assumption reflected an economy capable of absorbing the cost. Pressurization alone symbolized this difference. German engineers had experimented with it, but operational deployment remained limited. It required precise manufacturing tolerances and high-quality materials, both increasingly scarce in the Reich. The Americans treated it as a necessity, not a luxury. High-altitude bombing demanded it, and American industry could deliver it in quantity. Then there was the question of engines. The Wright R-3350 was among the most powerful radial engines ever placed into mass production during the war. It was complex, temperamental, and initially plagued by overheating. But instead of abandoning the project, American industry poured resources into solving the problem. New cooling solutions, improved manufacturing techniques, entire engineering teams dedicated solely to engine refinement. German engineers watching from afar recognized the implication immediately. These were not the decisions of a nation struggling to survive. They were the decisions of a nation confident it could afford failure on the path to success. By late 1944, fragments of direct evidence began to circulate. Allied technical publications captured in bombed cities, neutral intelligence exchanges, reports from Japan, increasingly strained under American bombing, filtered indirectly through diplomatic channels. The descriptions aligned: a very large bomber, exceptional range, advanced defensive systems, high-altitude performance unmatched by any European design. The B-29 was operating exactly as designed, far from its manufacturing base, sustained by a logistical network that crossed oceans. For German engineers, this mattered as much as its technical specifications. Germany's own long-range bomber projects had faltered not because of insufficient skill, but because the supporting infrastructure could not sustain them. Fuel shortages, material scarcity, and Allied bombing made even limited production a struggle. As the Reich's industrial map collapsed under repeated air raids, American factories remained untouched. Shifts ran day and night. Workers were trained faster than they were lost. New plants came online even as old ones expanded. This asymmetry was no longer theoretical, it was measurable. When German engineers placed the B-29 alongside their own unfinished designs, the Me-264, the U-390, they saw the difference immediately. Their aircraft existed on paper, in prototypes, in small numbers. The American bomber existed in squadrons, supported by spare parts, trained crews, and an unbroken supply chain. The realization did not come with anger, it came with clarity. This was not a race Germany could still win, not through innovation alone, not through courage or sacrifice. The B-29 represented a form of warfare in which the battlefield extended into factories, rail networks, and workforce demographics. It was the physical manifestation of an industrial reach that no amount of late-war improvisation could match. And as German engineers absorbed this truth, their focus began to shift from how to counter such a weapon to what its existence revealed about the war's final trajectory. Because the B-29 was not just a threat, it was evidence.
The first reaction among German engineers examining information on the B-29 was not disbelief, it was professional curiosity. These were men trained to look past propaganda and focus on structure, performance, and feasibility. They did not ask whether the aircraft existed, they asked how it worked. From a human perspective, this mattered. German aeronautical engineers were among the most technically sophisticated in the world. Many had spent their careers pushing the limits of materials science, aerodynamics, and propulsion. They had solved problems under constraints few others faced. And yet, when they analyzed the B-29, they encountered solutions that reflected an entirely different set of assumptions. The aircraft's sheer size was the first indicator. Large wings allowed for long-range lift at high altitude. A spacious fuselage permitted internal bomb bays, reducing drag and improving fuel efficiency. These choices prioritized endurance over agility. German bombers, designed for European distances, had rarely made such trade-offs acceptable. Then there was the crew environment. Pressurized compartments meant crews could operate at altitudes where German fighters struggled. From an engineering standpoint, this required precise sealing, robust materials, and consistent manufacturing quality. German engineers understood immediately what this implied. These systems could not tolerate shortcuts. They demanded uniformity across hundreds, even thousands of airframes. Remote-controlled gun turrets drew similar attention. German designs still relied largely on manually operated defenses, even as crew fatigue became a serious issue in long missions. The B-29's centralized fire control system reduced crew workload and improved defensive coverage. It reflected a design culture willing to invest in complexity to protect personnel. Each feature, examined individually, was impressive. Taken together, they formed a coherent philosophy. The aircraft was designed not for exceptional pilots, but for average crews operating under predictable conditions. This was mass warfare translated into engineering terms. Technically, German engineers recognized that many of these ideas were within their intellectual reach. Pressurization was not unknown. Heavy bombers had been studied extensively. Remote weapon systems had been tested. What differed was the ability to integrate all of these elements simultaneously, at scale, and under wartime pressure. The B-29 demanded tolerances that German factories, already strained by bombing and shortages, could no longer guarantee. Aluminum alloys of consistent quality, precision machining in large volumes, engines built not in dozens, but in tens of thousands. Each requirement multiplied the challenge. From a human standpoint, this realization cut deeply. German engineers had long believed that ingenuity could compensate for material disadvantage, that better design could overcome numerical inferiority. The B-29 challenged this belief directly. It suggested that at a certain scale, industrial capacity became a form of technology in itself. There was also an emotional undercurrent, rarely spoken aloud. Many of these engineers had entered the profession before the war, driven by a belief in progress and technical excellence. Now they saw that progress had moved elsewhere, not because of superior intellect, but because of superior organization and resources. In private assessments, the tone remained measured. No exaggeration, no despair, but the conclusions were stark. The B-29 represented a ceiling Germany could no longer reach, not in 1945, not without years of uninterrupted production, access to raw materials, and protection from air attack. As these evaluations circulated within technical and intelligence circles, they influenced how German planners understood the enemy. America was no longer merely an arsenal supplying Britain and the Soviet Union. It was the architect of a new kind of warfare, one in which distance offered no safety and attrition favored those who could replace losses effortlessly.
The B-29 did not intimidate German engineers through spectacle. It did so through logic, through numbers that added up too cleanly to dismiss. And as these men turned from blueprints to strategic implications, the question shifted from how such an aircraft was built to what it meant that it had been.
From a strategic standpoint, the B-29 forced German planners to confront a reality they had avoided for years. Until this point, the air war, however destructive, had remained bounded by geography. Bombers needed forward bases, fighters could intercept them, range and fuel imposed limits that strategy could still exploit. The B-29 dissolved many of those assumptions. An aircraft capable of intercontinental reach implied a world where no industrial center was truly beyond attack. For Germany, this was a grim recognition, but not the most unsettling one. The more profound implication lay in what such a machine said about its maker. A nation that could design, test, and field the B-29 during wartime had already solved problems Germany was only beginning to articulate. German intelligence assessments increasingly described American air power not as a collection of units, but as a system. Production, training, maintenance, logistics, and doctrine were aligned toward a single purpose: sustained pressure without exhaustion. The B-29 fits seamlessly into this system. It did not require extraordinary improvisation to deploy, it required organization. From the enemy's perspective, this realization reframed the conflict. The United States was not merely responding to Axis advances, it was shaping the future battlefield. German strategists understood that even if the Reich could stabilize its front lines, the industrial imbalance would only grow. Time, once Germany's ally in rapid campaigns, had become its enemy. The moral dimension was quieter, but no less present. Strategic bombing had already raised ethical questions within German technical circles. Engineers who designed aircraft understood their purpose intimately. The B-29, intended for sustained attacks on urban industrial targets, represented the culmination of this trend. Its capacity made earlier bombers seem restrained by comparison. Yet here, too, German engineers recognized an uncomfortable truth. The moral weight of such weapons rested not on design alone, but on the political and industrial systems that enabled their use. The B-29 existed because American society had accepted total mobilization. Its factories, workforce, and leadership were aligned in a way Germany's fractured wartime governance no longer was. There was no illusion that Germany could mirror this approach. Late war projects, the so-called wonder weapons, were driven by desperation, not coherence. Jet fighters, rockets, and advanced submarines promised breakthroughs, but arrived too late and in insufficient numbers. The B-29, by contrast, was neither miraculous nor hurried. It was methodical. Strategically, this difference mattered more than any single battle. German planners began to understand that the war's outcome was no longer dependent on tactical brilliance or even operational success. It was being decided in production charts, workforce statistics, and fuel allocations. The B-29 was simply the most visible symbol of this shift. Enemy analysis, once focused on aircraft performance, now expanded to industrial endurance. How long could America sustain such output? The answer, increasingly, appeared to be indefinitely. German estimates of American capacity were consistently revised upward. Each revision eroded confidence that the gap could ever be closed. For those tasked with advising leadership, the language remained careful. Defeat was not declared, but inevitability was implied. The B-29 represented a future in which Germany would always be reacting, never shaping. A future where innovation alone could not restore balance. By late 1944, this understanding filtered quietly into strategic thinking. Resources were diverted not toward matching American bombers, but toward mitigating their effects. Dispersed production, underground facilities, emergency measures designed to survive, not to win. The B-29 had done its work without ever flying over Germany. It had altered perception. It had forced a recalibration of expectations. It had made visible the industrial asymmetry at the heart of the war.
And as the Reich approached its final months, German engineers and strategists alike began to see the conflict not as a contest of weapons, but as a measure of what their nation could no longer become. This realization set the stage for the moment when understanding turned into acceptance.
The turning point did not arrive with an explosion or a single decisive report. It emerged gradually, through accumulation. By the early months of 1945, German engineers and intelligence officers no longer debated the nature of the B-29. They accepted it. The remaining question was what its existence revealed about the balance of power. Technical confirmations had become unavoidable. Reports from Japan, fragmented but consistent, described sustained high-altitude bombing campaigns conducted by large, four-engine aircraft operating from bases thousands of kilometers away. The performance characteristics aligned too closely to dismiss. Range estimates matched earlier intelligence. Payload figures were confirmed by the scale of destruction observed. Within German technical circles, comparisons were drawn openly. The Me-264, once envisioned as a transatlantic bomber, existed only in prototype form. The Ju-390 had flown, but in numbers too small to matter. Each suffered from familiar constraints: engine shortages, material limitations, and the absence of a stable production environment. None had reached operational maturity. The contrast with the B-29 was decisive. It was not merely that the American bomber existed, it existed in quantity. Squadrons could be lost and replaced without altering strategic tempo. This fact alone redefined what was possible in modern warfare. Recognition also came through self-assessment. German engineers reviewed their own industrial conditions honestly. Aluminum supplies were unreliable. Skilled labor had been depleted by conscription and bombing. Factories were dispersed, improvised, and vulnerable. Even if a comparable design had been completed, sustaining its production would have been impossible. This internal reckoning marked the true turning point. For years, German technological culture had been driven by the belief that innovation could reverse fortunes, that a superior aircraft, fielded at the right moment, could compensate for numerical disadvantage. The B-29 demonstrated the limits of that belief. There was no single document that declared defeat. Instead, assessments shifted in tone. Phrases like unlikely replaced possible. Timeframes extended beyond the war's plausible duration. Recommendations focused on mitigation rather than competition. Even leadership, often insulated from technical reality, could not ignore the implications. The idea of striking American industry directly, a dream that had lingered in the form of America bomber concepts, was quietly abandoned. The resources required were beyond reach. The war would end before such ambitions could be realized. For the engineers themselves, the recognition carried a professional weight. They understood that they were witnessing a transformation in warfare. Airpower had moved beyond the realm of national competition into one of industrial dominance. The B-29 was not a technological anomaly, it was a baseline for the future. As this understanding settled, it stripped away remaining illusions. The war was no longer about matching the enemy's weapons, it was about surviving the consequences of an imbalance that could no longer be corrected. And in that realization, the B-29 ceased to be merely an aircraft. It became a measure of what had been lost and of what could not be recovered. Once recognition set in, it carried with it a quieter, more unsettling question. Not how the enemy had built the B-29, but why Germany could not. This was the moment when analysis turned inward and the true weight of the imbalance became clear. German engineers compared timelines. The conceptual foundations of the B-29 had been laid before the war, refined steadily, insulated from sudden shifts in political demand. In contrast, German long-range bomber programs had been repeatedly disrupted. Specifications changed, resources were diverted, strategic priorities shifted with each campaign. Aircraft were redesigned mid-production to meet new demands, sacrificing reliability for urgency. The loss was not technical knowledge.
German designers understood aerodynamics, metallurgy, and propulsion as well as any in the world. What had been lost was continuity, the ability to commit to a project for years, protected from interference, supported by stable production. The B-29 embodied this continuity. Its development absorbed setbacks without cancellation. Engine failures led to investment, not abandonment. Structural challenges resulted in redesigns, not compromises. Each problem was treated as solvable because the industrial foundation made patience possible. In Germany, patience had become a liability. By 1944, every decision was weighed against immediate survival. Projects promising results beyond months were sidelined. Engineers were ordered to produce faster, lighter, cheaper, often all at once. Quality suffered, reliability declined. Even successful designs struggled to reach the front in meaningful numbers. The B-29 forced German technical elites to confront the consequences of these conditions. They saw that industrial warfare rewarded not brilliance alone, but stability, not ingenuity alone, but scale. America's advantage lay not in a single innovation, but in its ability to sustain thousands of incremental improvements without collapse. This understanding reshaped how German engineers viewed their own legacy. Many had entered the war confident that European technical leadership would endure, that Germany, with its universities and research institutions, would remain at the forefront of aviation. The B-29 suggested otherwise. It marked a transfer of dominance. There was also a psychological dimension. Engineers are trained to solve problems, to believe that with enough time and resources, solutions exist. The B-29 represented a problem Germany could no longer solve because the conditions required for solving it no longer existed. Late war efforts, jets, rockets, advanced submarines were impressive but isolated. They lacked the integrated support that made the B-29 effective. Without fuel, trained crews, maintenance capacity, and spare parts, even the most advanced weapon became fragile. As Allied forces closed in and the Reich's infrastructure disintegrated, this realization hardened into acceptance. The war would not end with a technological reversal. It would end because one side could replace losses indefinitely, while the other could not. For German engineers, this was perhaps the most difficult truth to accept. Not that they had been outthought, but that they had been outproduced. The B-29 did not simply represent American power. It represented a future in which warfare would be decided by systems larger than any single weapon or nation's ingenuity, a future Germany had helped shape intellectually but could no longer participate in materially. And as the war's final weeks approached, the significance of this loss extended beyond defeat. It pointed towards a post-war world where industrial scale would define leadership and where the lessons of the B-29 would shape air power for generations. That future was already arriving.
By the spring of 1945, the consequences of what the B-29 represented were no longer abstract. They manifested daily in Germany's shrinking options and narrowing horizons. The Reich did not face defeat solely because of advancing armies or collapsing fronts. It faced defeat because it could no longer shape the character of the war being waged against it. German responses to American industrial air power became increasingly defensive. Production facilities were dispersed into forests, tunnels, and underground complexes. Assembly lines were broken into smaller units to reduce vulnerability. These measures slowed destruction, but they also reduced efficiency. Every safeguard imposed a cost Germany could no longer afford. There was no serious attempt to counter the B-29 directly. German fighters lacked the range to threaten its bases. Anti-aircraft defenses, already stretched thin, could not be redeployed to meet a bomber that never appeared over German skies. Even intelligence efforts shifted away from technical countermeasures toward estimation. How many existed, how fast they could be produced, and how long such output could be sustained. The answers were discouraging.
By early 1945, German analysts understood that American aircraft losses in the Pacific were being replaced faster than Japanese defenses could inflict them. This dynamic mirrored what Germany itself was experiencing over Europe. The war had become a contest of replacement rates, and Germany was losing decisively. Resources that might once have supported long-term aviation programs were redirected towards short-term survival. Jet fighters like the Me-262 were rushed into service without adequate pilot training or fuel supplies. Rockets promised psychological impact but consumed enormous industrial effort for limited strategic return. Each project reflected urgency rather than coherence. The B-29 cast these efforts into sharp relief. It demonstrated what a fully supported weapon system looked like, one embedded in doctrine, logistics, and industrial planning. German programs, by contrast, appeared increasingly isolated, impressive on paper, but fragile in practice. For civilian populations, the effects were indirect but profound. As Allied bombing continued to dismantle transportation networks and factories, shortages intensified. The contrast between Germany's strained output and America's uninterrupted production became visible even to those far removed from engineering circles. The war felt endless for one side, inexhaustible for the other. Within the military, strategic confidence eroded. Commanders could no longer promise that new weapons would change the course of the conflict. The language shifted toward endurance, containment, and damage limitation. Victory was no longer framed as attainable, only delayable. In this environment, the B-29 functioned less as an active threat and more as a symbol. It represented a level of coordination and capacity that Germany could neither attack nor replicate. Its very existence underscored the futility of late-war improvisation. As Germany's final campaigns unfolded, the industrial imbalance defined every decision. Fuel was rationed, training hours were cut, aircraft were grounded for lack of spare parts. Meanwhile, American production lines continued to expand, untouched by the war they sustained. The outcome was not sudden, it was cumulative. Each month reinforced what German engineers had already concluded in their assessments. The war had outgrown the tools Germany could still wield. And as the fighting drew closer to an end, attention began to shift from immediate consequences to what would follow. When the machines were silent, and the reckoning began.
When the war ended, German engineers emerged into a world reshaped by the forces they had spent years analyzing from a distance. The machinery of defeat was dismantled quickly. Factories were occupied, documents were seized, prototypes were cataloged and shipped abroad. For many, the transition from wartime urgency to post-war scrutiny was abrupt. Allied investigators moved with precision. They examined German research facilities, interviewed engineers, and assessed unfinished projects. What they found confirmed much of what German technical elites already knew. Innovation had been real, skill had been abundant, but the supporting system had fractured under pressure. In contrast, the B-29 stood as a completed chapter rather than an experiment. Its role in the final year of the war and its continuation into the immediate post-war period reinforced the lesson German engineers had learned too late. Industrial scale was not merely an advantage, it was decisive. Many German engineers were soon absorbed into Allied programs. Some contributed to American aviation research, others worked in reconstruction or civilian industries. Their expertise remained valuable, but the context had changed. They were no longer defining the cutting edge. They were contributing to a system already in motion. The B-29's legacy extended far beyond its wartime missions. It influenced post-war bomber design, strategic doctrine, and the emerging concept of global air power. Pressurization,
long-range endurance, and integrated systems became standard expectations rather than exceptions. The aircraft had set a template. For Germany, the reckoning was both professional and national. The war had demonstrated that technical excellence could not compensate indefinitely for strategic and industrial imbalance. The belief that superior engineering could offset material disadvantage had been disproven decisively. This realization shaped post-war thinking. European aviation would rebuild, but within a new hierarchy. The center of gravity had shifted across the Atlantic. American industry, tested and proven under the most demanding conditions, now defined the pace of development. German engineers reflected on the war with a mixture of pride and resignation. Pride in what had been achieved under extraordinary constraints, resignation in recognizing the limits of those achievements. The B-29 had illuminated those limits with uncomfortable clarity. It also served as a cautionary example. Technology, divorced from sustainable systems, could impress but not endure. The future belonged to those who could align innovation with production, doctrine with logistics, and ambition with capacity. As the world entered a new era of rivalry and reconstruction, the lessons embedded in the B-29 did not fade. They informed Cold War planning, deterrence strategies, and the belief that air power could shape global order. For those who had once examined its specifications in dimly lit rooms, the meaning was clear. They had not simply studied an aircraft, they had witnessed the arrival of a new standard. And with that standard established, the final question was no longer who had won the war, but what it had revealed about the nature of modern power.
The B-29 was more than metal, engines, or weapon systems. It was a mirror reflecting the industrial and organizational might of a nation mobilized for total war. For German engineers, poring over its blueprints and photographs in those final months, it revealed a truth that no battle could convey. Mastery of technology alone does not win wars. Scale, infrastructure, and societal alignment matter just as much. In those quiet rooms, amid measured calculations and silent acknowledgments, they confronted an uncomfortable lesson. Their skill, honed over decades, could not match a system built to absorb mistakes, replace losses, and operate without pause. The war had outgrown any single genius. The B-29 embodied that lesson in wings that spanned continents, engines that demanded endurance, and a design philosophy rooted in the capacity of a nation rather than the brilliance of an individual. Yet there was also a somber clarity. The story of the B-29 was not only about victory or defeat, it was about human endeavor at its largest scale. It highlighted the extraordinary possibilities of organized effort, the quiet power of planning and production, and the cost of losing the race to match them. Engineers who had once dreamed of German dominance could only acknowledge a new reality. The war had shifted, and the world had shifted with it. History would remember the B-29 for the missions it flew, the cities it struck, and the post-war aviation it inspired. But for those who understood it, as German engineers did, it represented something deeper, a revelation that technology alone is never enough, and that the measure of a nation at war is as much industrial as it is military. In the end, the B-29 was a symbol, not of American ingenuity alone, but of the scale, patience, and coordination that define modern power. And in that symbol lay the quiet lesson of the war's final years. Survival, dominance, and progress are determined not just by what a nation can imagine, but by what it can sustain.